Today I'm going to show you how to get a mirror finish like this without ever turning your spindle on. Now, why would we not turn the spindle on? Why is that important? Well, come a little closer and let me show you why. Now, when we take a look at this under certain lighting, it looks really great. It looks perfect. But as I start rotating this around, I can start to see the imperfections in here. And the imperfections that I'm seeing are these little curled radius cuts in it. I can tell that it's coming from my spindle. So maybe the logical solution here is to not turn the spindle on. But will it really make it better if the spindle is not spinning? Well, let me show you a quick example and talk about some of the things that you got to think of when you're spinning at a high rate of speed. So we're running this part on our Emco UMIL 630. Now there's a lot of factors that come into play whenever you're talking about getting an ultra fine finish on a CNC machine. Whether it's your tool, your holder, your spindle, your work holding, there's just a lot that goes into it. Well, today we're really going to specifically look at the tool and the holder. If you're really running at high RPMs, you need to balance your assembly. But another thing that most people don't think about is resonance from your spindle itself. Now, every spindle is going to resonate differently at different RPMs, and I want to give you a quick example of that here. I'm going to turn my spindle on at 11,500 RPMs. When I hit cycle start, you can hear that vibration in that. Now, it's not bad in the grand scheme of things. It's not like, oh, there's something wrong with my spindle type bad. It's just at this RPM, I'm getting a little bit more of a resonance than I'm used to. And now watch this. I'm going to go to 15,000 RPMs. This is the max for my spindle. Now that's a little bit better, right? Even at that higher RPM. It's a little bit higher pitch, but it's not resonating as bad. Now let's drop it down to 14,000. That's even quieter, right? So that seems to be the sweet spot for my spindle on this machine. So that sounds better than 11 and even better than 15. It doesn't necessarily mean going up or down is going to make the resonance better. You just need to find where it is that your machine wants to sound the best or resonate the best if you're trying to get a really good finish. Now, for what we're trying to do, getting a mirror finish, this might be good enough and it might not. Now, you saw on the part earlier that we got an extremely good finish, but we're just not quite there yet. So let me show you one more that actually sounds better than this. Oh yeah, see, I can't even hear that. That's perfect. That's exactly what I want. So now we saw what the part looks like at 14,000 RPMs. Now let's stop the spindle, lock it into place, and see if we can't get that finish even better. All right, let's talk about some of the things that's going on here while this is running. Right off the bat, you're going to notice that I'm not running coolant. Now that is just for your viewing pleasure. That's not going to give us the best finish, not running coolant. But what I am going to do periodically is try to stop it, blow the chips off very lightly, and hit it with some WD-40. If I'm not getting a really good finish then, I'm probably going to go back and run it with coolant. But just so you know, I'm only doing that for you guys. Now let's start talking about this process as this starts running through here. Now the first thing that we're going to talk about is the tool that I'm using. You probably already guessed it, this is an MCD, monocrystalline diamond. But this one's going to be different than the ones you saw us use in the past. This one is not a ball nose. Now I've used an 8mm ball nose on the drum. You might have saw other videos that Trevor did where he used a 6mm ball nose. This one is a circle segment lens cutter. We recently did a video where Dre used a lens cutter on a 3-axis machine. In that video, he kind of explained how it's got a very large radius at the bottom and it's not just a flat tool. This one is very similar to that. This is a 10mm diameter tool, or 394 thousandths, with a 100mm radius along the bottom and the side. So that's like using a 200mm diameter ball nose, all while the tool is only 10mm diameter. We can drastically increase our step over because it's like we're using a giant ball nose tool. But we're going to have to help it out with the process, right? So You might not be able to notice this, but I am rotating over on a 2-degree angle. So that is to get the contact point closer to the edge of this tool. This tool doesn't go all the way across the bottom, right? A diamond tool is extremely expensive to make. So they've only given me about 4 millimeters along the bottom and along the side. So I'm tilting up at 2 degrees to get that contact point closer to that edge. So another thing that I'm doing is I'm timing the spindle to control how the chip is formed. So what I've done is I've indicated that insert flat, and then I rotated it back because I'm going from, well, depending on how you're looking at it, from left to right. So what I want to do is rotate that spindle to where the insert has a little bit of negative rake on it. That way when it forms the chip, it's forming on the side that I haven't cut yet. So that's going to keep the chip from scratching the surface that I've already cut. Now another thing that you'll notice as this runs across here, that the program starts to get a little inefficient, right? That's because I hand wrote this with a macro. And now I did that because I didn't want the spindle to lift up and come back down every pass as it moves across the part. Every machine is going to have a positional and repeatability accuracy. Okay, there's going to be some type of error there and even backlash. And it might not be much, but I don't want that to reflect in my part, so I want to remove that element. Now that might be overkill for what we're doing. Honestly, I could have just posted it out in SolidCam, just a normal surface milling toolpath, and then delete the spindle command. And then just add in the positional rotation that I want, and then just use that toolpath. I actually got some of these ideas from another channel called Breaking Taps. He did an amazing video on nearly this exact circumstance. Only his video, he was truly trying to go after an optics quality mirror finish, where we're not doing that, but we do want the best thing we can do. So I've taken some of the ideas that he had in that video and I've applied them here. All right guys, so check out that finish. We solved that problem of having those swirl marks and those scratches due to spinning the spindle and the vibrations we were getting there. Hopefully you guys learned something from this video and you can take something from it and apply it to your scenarios. So if you need a finish like this, check out these MCD tools from Horn and try some of the methods that you saw here today. That's going to do it for this video, guys. Hit that like and subscribe button. We'll see you on the next one.